Hey everybody, this is Franco, and I am going to shoot a video that I've been promising to make for a long time. I'm finally getting around to it. And just right off the bat, I don't have a lapel microphone. I'm doing this with an Android mobile phone. I apologize. I'm going to try to speak as loud as I can, and hopefully you can hear everything I say. So this video is about stepper motors and servo motors, and comparing the different types. So what we have here, we have three different options that are fairly popular. You may want to zoom in while I'm talking about this. So the first option right here, this is the DM542A Driver from Long's Motor. It's being driven by a 350 watt 36 volt power supply. And then this is your old standby, your 23 HS9430B stepper motor. So this is sort of the low cost option. This motor, this driver, this power supply, you can buy these on eBay anywhere between, this whole set, anywhere between $65 to $165. So often these are sold in bundles, maybe 4 of everything. If you're buying them that way, it's going to be more like $65. If you just buy one motor, one driver, one power supply, $165. So this is the low cost option. Over here is maybe what we'll call, the middle ground. This is an HBS860H hybrid stepper driver. It's being driven by a 200 watt 36 volt power supply. And then this is the 57 HBS30 hybrid stepper motor. So these are also sold on eBay. I believe the seller that usually sells these things is called FastToBuy. And this package right here, if you buy this motor, this driver, this power supply, will cost you about $210. Now, just an added point, if you buy the programming cable, I believe that's an additional $15. So let's just say $225 for this motor, this driver, this power supply, and the programming cable. All right, and then if you move over here, we have what I guess we would describe as the high option. So this is the DMM DYN2-TLA6S-00 Driver. It's being driven by a 350 watt 48 volt power supply. Then of course you have the 57N DHT-A6TD1 servo motor that goes along with it. Now, something that you have to point out with these DMM drivers is, in addition to the driver, the motor, and the power supply, you also have to buy a cable. So there's a servo cable, and then there's an encoder cable. That adds another $46 into the price of this package. Beyond that, you also need the programming cable, and that's an additional $32. So if you add that up, you have $386 for the motor, the driver, the power supply, and another $32. So what's that, $418? So $418 to get this motor, this driver, this power supply, and the programming cable. So those are the three options. You have the inexpensive, kind of the middle of ground, and then you have like the higher end, higher performance motor driver combination. So let me just talk about this a little bit. We discussed the price. Obviously price is a factor, but some other things are also worth talking about. Customer service. So let's talk about the customer service that you get with these three different companies. So the Long's Motor products, you buy these off eBay. They're imported, from overseas. The customer service, you're basically limited to what you get through eBay, what you can find on the internet. Basically, the stuff's going to show up. It's either going to work or it's not. And if it doesn't work, you do the whole eBay thing, leave positive or negative feedback and hope you can get a response. But, in general, the people that sell these are nice people. But, not a whole lot of customer service with this. You basically just get what you get. The hybrid stepper motors that are being sold by FastToBuy, very similar type of thing. These are sold on eBay. And They don't come with a whole lot of documentation. What they do come with is usually in Chinese. So if you're searching for information on these, you know, there's videos and things on the web. I have a couple of videos about these drivers and motors with information that I found, but kind of the same thing. You're basically limited with the type of customer service you're going to get with these. It's pretty much what you find on eBay, on the internet, or from YouTube videos. Then over here, we have the DMM product. Their customer service model is different. So these are, you know, manufactured in China, but they're distributed out of Canada, and they have customer service that's well, it's a lot better than what you're going to get, you know, from the other two options. So you can actually send an email to a real human being, and they will respond to you, and they will ask you or answer your questions. They will take time to help you spec out your motors, find the proper components for your application. So the level of customer service with the DMM products is much higher. And I can speak to this personally. I've had a personal experience with these guys. When I first hooked up this DYN drive setup, I very foolishly forgot to switch the power supply from 220 volt to 110 volt. So I hooked this whole thing up with the power supply switched to 220 volts when I was running it off 110 volts. It didn't work very well. I had nothing but problems, and I ruined the power supply doing that. Just never occurred to me to check the switch on the power supply. So I hooked it up, I tried it didn't work well for me, and I sent some emails to the people at DMM that were helping me out. And I wasn't rude, but I wasn't friendly either. I just kind of told them, like, hey, this didn't work so well. I'm not sure if I'm into your products. And they took a lot of time. They took everything back. They tested it. They were very nice to me. And then, you know, so they left me with a very positive impression. So in spite of my own stupidity, they helped me get through that problem. And I will say that was a strong testament to the level of customer service that they provide. Really nice people, very helpful. All right, complexity of the electrical connections. So we'll go back here to the cheap option. So these are pretty simple. You want to zoom in over here. Okay, don't worry about the cat. Winston's in the garage and he's not very happy about being in the garage. Okay, let him back in the house, whatever. Okay, Winston, go back in the house. Okay. This is the low option. As far as complexity, this is very simple. There's no software to worry about with this product. Basically, everything you do is set with dip switches here on the side of the drive. There's dip switches right there. And all the settings are right on the front of the drive. So these things are very easy. They're very simple. There's not a lot of complexity with this. That's all there is to it. Now if you come over here to the hybrid closed loop stepper, there's dip switches, and the dip switches are used to set the steps per revolution, just like the Long's motor product. But there is a little bit more complexity with this. So the first thing that I'll point out is there's software that comes with these drives. And I'm going to show it to you right now. If you look at this screen, this is the software that you can use to program the drive. You can change parameters in the drive. You can do all sorts of things to it. You can also invert the inputs and outputs on this drive. So some nice things. Software also lets you do things like monitor the motor while it's running and do some testing and different things like that. But that is the software that you use with this programming cable. So it adds a little bit of complexity. Now here's the catch. The way these ship from the factory, you don't have to use the software. You basically can take them out of the box and use them as is. Once again, you can do the steps per revolution with dip switches on the side. So you don't have to have the software, but if you want to get a little deeper into it and really tweak this thing, you will need the software. Another point that I'll make, this has signal outputs for alarm status, so you can connect to these signal outputs to tell your CNC software, like for instance, I'm using the Centroid Acorn board. You can very easily wire in this alarm output into the Centroid Acorn board or whatever other board you're using. And if for some reason this drive faults out, it tells the software that it's faulted out and everything will stop. You don't have that option with the Longs motor product. With this, the hybrid stepper, you do. All right, moving on up to the DYN2 drive. Okay, this is probably the most complex of the three, also because it's the highest performing thing. There's no dip switches on this drive. Everything on this drive has to be configured through the software. And here's a screenshot of the software right here. And of course my computer is frozen up on me, so let me pause this video. Oh, hang on. Let me try this again. So here we go. We're going to detect a COM port. Looks like it's on COM 8. Set it to COM 8. Set COM port. It's happy. And then you go into servo settings. You choose DYN2. You read the drive. And these are all the current settings that are in the drive right now. So once again, you absolutely positively have to use the software to configure this drive. I'm not going to get real deep into the settings. If you want to know more about that, you can read the manual. The only one I'm going to point out right here, this thing right here, gear number, this is actually how you set the pulses per rev. And the trick with this is it's 1/4 of what you actually want it to be. So right now, the gear number is set to 500. That means it's going to take 2,000 pulses per revolution, or it will require 2,000 pulses to make one revolution. So that's all described in their manual. It's just worth pointing out. Other things that are worth mentioning with the DYN2, you'll notice I have these two big 1,000 microfarad capacitors on here. This is something the manual recommends. They want you to hook these capacitors up to basically help smooth out the power supply. Once again, this is a higher performing drive, so it needs a little bit more than maybe what the other stuff would. So definitely the most complex to configure. Now, as far as wiring this stuff up, fortunately, I'm using the Centroid Acorn products, and the Centroid people give you really good wiring diagrams, very detailed information, and I have basically hooked all of these drives up using this schematic as a reference. So just one point that I'll make, this may not necessarily be the way you would hook these up in your machine installation. This is just what I did to bench test it. I don't have any of the alarm signals going back to the Acorn board from the hybrid drive or from the DYN2 drive. The other thing that I'm going to point out is if you are going to go with these DYN2 drives, go over to Marty's CNC Garage, check his YouTube channel out. He has put a lot of work into describing the best way of hooking up these DYN2 drives up to the Centroid Acorn board. So if you are going to use the DYN2 drive, go over to Marty's CNC Garage and he will give you probably the best instructions you can find right now on using that product. All right, let's go on to the next section, performance. So once again, this is an open loop system. There is no feedback from the motor to the driver, and there's no feedback from the driver to the CNC control software. There is just no feedback with this, so this is why it's one of the lower, it's one of the lowest cost options. When you go to the closed loop hybrid stepper motor, you have feedback from the motor to the drive, so the drive knows where the position of the motor is and it can compensate to correct for it. And it also provides this alarm output that you can wire into your CNC control board. Same thing with the DYN2 servo. There's an encoder on this servo. The driver knows where the motor is. It dynamically corrects things. And then you can also wire in an alarm output from the driver back to your control board, like the Centroid Acorn. So here's a little point. So comparison between servos and stepper motors. Servo motors do not lock into their position as tightly as stepper motors, but they are more powerful once the motor starts rotating. So long story short, stepper motor does a better job of staying still. The stepper motor, if you're designing something that's going to be locked in position most of the time, maybe you want to go with the stepper motor. But the servo motors, they maintain torque as they're spinning. So the stepper uses almost 100% of its power all the time. When it's locked into position, it uses a lot of power to make sure that it's locked in. The servo system uses almost no power when it's locked into position. The only time it uses power is if it detects something moving. So while it's sitting still, the servo really doesn't draw much power. Once the stepper motor starts to rotate and you increase the speed, the stepper motors start to lose torque. So that's something you'll see when you look at the torque curves for these motors. The faster they go, the less torque they have. But the servo motors, they only use as much energy that's needed to maintain torque. And that's pretty consistent until you get to a really high RPM, like 3,000 RPM. Once you hit about 3,000 RPM, the torque drops off, and then between 3,000 and 5,000, who knows what's going to happen. But long story short, the servos do a much better job of maintaining torque and power as you're adding RPM, where your stepper motors, they just continuously lose torque as you increase RPM. Stepper motors, the way that they're made, there's a limit to the position and the resolution that they can, you can get out of them. The servo systems have almost an infinite amount of resolution. So that's a big deal. Okay, so a little bit of testing here right now. The minimum pulse per revolution that I can set on the servo is 2,000 pulses per revolution. It won't let me set it to anything less than that. Right now I have this hybrid stepper set at 1,000 pulses per revolution, and I have this regular open loop stepper set to 1,000 pulses per revolution. So we're going to do a little bit of testing with these right now, and I've kind of made an assumption. I've made an assumption that a lot of people are going to be using these rolled ball screws. These have a pitch of 5 millimeters. So that translates into 5.08 revolutions per inch. So the way that I configured the CNC12 software, I'll just show you for the sake of testing. Actually, it's the wrong screen. Here we go. So right now, x-axis is 1,000 steps per rev, y-axis is 1,000 steps per rev, and z-axis is 2,000 steps per rev. And they're all set to 5.08 revolutions per inch. So X is the open loop, Y is the hybrid stepper, and Z is the servo. All right, so we're going to do a little bit of testing here, and I think these settings are pretty good. So at 1,000 pulses per revolution, your actual machine resolution would be 2 10,000ths of an inch. So right now, assuming you use those 5 millimeter pitch ball screws, this motor and this motor would give you a minimum increment on your machine of 2 10,000ths of an inch, so 0.0002. The DYN servo, obviously right now, it would be half of that. So this is going to, at its minimum setting, with this ball screw, will give you a resolution of 1 10,000th of an inch, or 0.0001. So let me pause the camera and get this test going. I'll show you what we're going to do. Okay, if you zoom in on this program, basically what we have is a looping program that's going to, first we're going to run the x-axis, and this thing's going to continue to loop. It's going to continue to increase the RPM. And what I'm going to do is run this program while the camera's on the motor, and then I'm going to show you which, or tell you which feed rate it bombs out at. So, I want to zoom in on this motor right there, and we will begin. All right, we're up to 80 inches per minute, 90, 110. You can hear it, it's making some noise. 150, 170. All right there, 190. It's starting to miss steps. There you go. At 270, it's totally choking out. So the open loop stepper, like I said, at 190 inches per minute, I could feel it starting to lose steps with whatever resistance I could apply with this rag. And then, like we said, around 270, it just totally dies. So there you go. So there's the open loop stepper. So now we're going to do the same thing with the hybrid stepper. Let me edit my program here really quick. Now we're going to perform the same test with the hybrid. Here we go. It's 50, 60. 110, 120. Up to 180. 210. 240. 270. Trying to apply a little bit of resistance here. 310, 320, 330, 340, 370. I'm going to set this rag on fire. 390, 400. We're up to 430, 440. 460, 490, 500. There we go. So at 500 inches per minute, 500 inches per minute, the closed loop stepper bombed out, and you can see the alarm light is flashing on the drive. And if we just take some temperature readings right now, we're at like 120 degrees Fahrenheit with the laser thermometer. So there you go. Obviously, the hybrid stepper does a whole lot better than the open loop stepper. So now let's go over to the yeah. We could call it the hot stepper because it's hot. Yeah, we could call it that. Okay, so now we're going to do the same experiment with the DYN2 drive. Now remember, the first two were set to 1,000 pulses per revolution. This is set at its minimum setting at 2,000 pulses per revolution. So let's get that going. And let me just edit the program quick. Run the Z-axis. All right, here we go. Now notice how quiet this is. That's the first thing that's going to jump out at you. Also notice how much less this motor jumps around on the table. So we're at 120. $180, $200, 250. $300. Got $350. $400. $450. There's 500 inches per minute. You can see how smooth this thing is. There's far less vibrations. At 550. I can't hardly keep this rag on it now. It's getting too hot. 590, 600 inches per minute. $650. Well, there we go. 650, 660 inches per minute it bombs out. So notice how quiet and how smooth it was. It's really impressive. And now I'm not going to lie to you. If you flash up on the screen, I haven't played with the settings a whole lot for this servo. I know I can tune this servo to get more power out of it. I know I can adjust the gain. Right now it's at a very low setting. We can turn that gain up and get more power. But what I'm going to do right now is I'm going to go back and I'm going to increase the resolution on this motor. I'm going to take it up to more pulses per revolution. We're going to run the same experiment and repeat it again with the servo motor at a higher resolution. Let's change the setting for this DYN2 drive. I put the gear number up to 1000. That means 4000 pulses per revolution. So let's go ahead and rerun the program and let's see how fast this thing goes before it bombs out. That's 50. $100. $150. $200. We're at $250. $300. Still has a lot of torque. That's $350. $400. Winston likes this, okay. We're at $450. $500. That's $550. $591. I think what I've done is I've hit the maximum pulse rate for the software and for the driver board. So I actually can't run this motor fast enough to make it bomb out. Using one of these 5mm pitch ball screws at 4,000 pulses per revolution, I max out at 591 inches per rev. So, just like they said, you don't lose torque as you add speed. And you can see increasing the pulses per revolution doesn't seem to drop off the torque on the DYN2 servo. That was exciting. I guarantee you if I went back and increased the pulses per revolution on these stepper motors, the torque would reduce quite a bit. And if you look at the torque curves for stepper motors, you can see that. As you increase micro-stepping, you start to lose a lot of torque. But with the servo motor, that's not the case. You can also see this motor is running very cool compared to the steppers. So right now, this motor is only 94 degrees. I'll bet you this motor's been sitting for a while. Yeah, this motor's been resting for a little while. It's still hotter than the servo is while it's running. So, what does this all mean? Well, obviously these servos cost more money than the stepper motors, for sure, right? You don't need to be a rocket scientist to figure that out. But they are definitely higher performing motors. So depending on the system you're building, if you have the right application, then you definitely can take advantage of the higher feed rates, the higher resolution that the servo motor can give you. But there's a place for these hybrid steppers. I really like these because of the price, and it's a good combination of price and performance. And if you're building a simple machine where you're on a budget, these open loop steppers, they're still a good value too. But definitely differences in performance. So I'm really impressed with these DYN2 drives. I think this little experiment really proves the point. When it comes to performance, these things are top notch. And that's why you'll see, a commercial CNC machine will always have servos. You really will never see steppers in a commercial CNC machine. And I've noticed a lot of machines are shipping with the DMM products in them from the factory. So yeah, they're more expensive, but you get more performance. Well, all right, well that's it. Thanks for watching. I hope this was informative, and please be safe when you're working on your projects, and thanks for watching.